Good morning, one and all. In the last class, we discussed about how we documenting the software architecture and uses of software architecture documentation, and we are discussed in so many uses about architectural documentation. In this class, we discussed about views. The another concept is views. Okay, we want to create a software documentation. So, what are the views we can follow? That is the main concept here. Perhaps the most important concept associated with the software architecture documentation is view. So, we can see what is view first of all. Define a software architecture for a system as the structure or structures of the system, which comprise elements, the externally visible properties of those elements and the relationships among them. Okay, na? So, what is the view? The view defines, the view specifies the structure or the structures of the system. That is the view. First, once we can saw the view, we can saw some structure or structures of the system. Suppose, when we saw a building, we can view in different ways: top view, front view, side view, bottom view. So, when you saw a particular view or a particular angle, we saw some structure. This is one structure, this is another structure. When we saw front view, we can see overall the structure of a building. So, this is the different ways we can see some structure with different views. That is why we can define a software architecture for a system as the structure. It is a structure or a structures of the system. We are having multiple structures of a particular system, which comprise what the system comprise, what the system again describes as it comprise the elements. So, what are the elements we are using in this particular structure, or what are the external visible properties of a particular elements, and what are the elements or what are the external visible properties of a particular elements, and also this defines the relationships among them. The relationships among them. What is the among them means? Among the elements and among the external properties of those elements. And we said that a view is a representation of a coherent set of architectural elements. Another way we want to define a view is, the view is representation of coherent set of architectural elements, the related set of architectural elements. That is the meaning of coherent set of architectural elements, as written by and read by system stakeholders. It can be written or read by the system stakeholders. A structure is a set of elements itself. That is a structure. View is a representation of coherent set of architectural elements, but a structure is a set of elements itself. That is the difference between view and structure, but the different views is cumulatively is called as a structure. That is finally. That means a structure is the set of elements itself as they exist in software or hardware. Either it may be a software architecture software, either it may be exist in a hardware. Okay, now we are having the suppose we can, when we saw the computer architecture or a block diagram of the system, when we discuss about the components of a computer. So, we can discuss about either software components and hardware components. We are having the major two types of parts or two types of components of a computer. For example, hardware components and software component, as well as in this also it can exist in either in software or either in hardware. And also a software architecture as a complex entity that cannot be described in simple or one dimensional fashion. It is a complex entity. Software architecture and a concept, it is a complex, means a big entity that cannot be described. We can't describe in simple way. We can't explain or describe in a single one dimensional fashion. Okay, na? That's why we will go for multiple dimensions. When we prepare this software architecture, we can go with multiple dimensions. Okay, na? Means more than one dimension or not a single dimension. Why? Because it is a complex entity. Software architecture is a complex entity. That is why we will go through it multiple dimensions in multiple dimension fashions. The analogy with the building architecture, if not taken too far, proves illumination. Okay, now there is no single rendification of a building architecture, but many. The room, so for example, when we saw a building, it is not a single rendification. Okay, it is not for a particular room, it is not for a particular. When we want to describe about a particular architecture of a building, so what we saw in general, the room layouts, the elevation drawings, the electrical diagrams, the plumbing diagrams, the ventilation diagrams, the traffic patterns, the sunlight and the passive solar views, the security system plans and many others. So, we want to build a particular building architecture, we are not rendering on a single layout, we will be on many. Okay, now what are those? We will saw on a rooms layout, we will focusing on evaluation drawings and the electrical diagrams. So, how we can give the electrician to the particular house, which type of ways and all, plumbing diagrams and also ventilation diagrams, the traffic patterns and sunlight and passive solar views and security system plans and many others. We can focus on this group of them, not in a single rendification. So, when we are going to construct a particular building, okay, architecture, that is the view. We can saw in different views. These all are the listed views. We can observe the things. That is the main importance of a view. And the concept of view, which we can think as a capturing a structure. The main concept of view is what? It is capturing the structure of a particular building or a particular architecture, whatever it may be. It provides with us the basic principles of documenting software architecture. What is the use of this view? It provides the basic principles for us to documenting a software architecture. That is the main use of views for preparing a documentation of a particular software architecture. Okay, now it's capturing the structure of a particular thing. Documenting an architecture is a matter of documenting the relevant views. So, we want to discuss when we discuss about the documenting an architecture is a matter of what? It is documenting the relevant views. Okay, now when we prepare the documentation, definitely we will preparing regarding to the particular related things that is among relevant views, and then adding documentation that applies to more than one view. So, according to that, then we individually we can focusing on the views, relevant views, then we can adding them for the particular documentation that applies more than one view. Okay, na? That is the main importance of these views while documenting the software architecture. The principles is useful. The principles is useful because it breaks the problem of architecture documentation into more tractable parts, which provides the structure of the remainder of this chapter. According to this, this view follows some principles. These are useful. It breaks the problem of architecture documentation into more tractable parts. Okay, now that is the main importance of these views. So here we can see the major three types of views. Choosing the relevant views first, documenting a view, documenting information that applies to more than one view. In this we are going to learn choosing the relevant views. First we can choose the relevant views. According to that we can documenting a view. Then documenting information that applies to more than one view. Okay, now that is the thing. First we can choose, then we can prepare the documentation for a view, then adding the information of the particular documentation to apply more than one view. That is the main thing here. First, according to the first one, choosing the relevant views. So how to choose the relevant views? Okay, while documenting a software architecture, the quality attributes of most concern to you and other stakeholders of the system's development will affect the choice of what views to document. This is the choice of stakeholders. It affects the choice of what views to document. For instance, a layered view will tell you about your system's property or portability. So in generally, while documenting these views, so we can think about which type of views we can documented. So for example, for instance, while you are talking about layered views, what is the purpose of this layered view? It tells about your system's portability. The layered view tells us the system portability. A deployment view will tell you reason about your system's performance and reliability. The layered view tells about system portability. The deployment view tells the reasons about our system's performance and reliability. So these layers or these views are gives different types of information to that particular stakeholders, and these quality attributes are spoken for in the documentation by analysis. According to these quality attributes is mainly used for analysis, who need to examine the architecture to make sure the quality attributes are provided. Then in short, different views support different goals and uses. Why we gather different views, why we choose different views means in short we want to tell it different views support what? Different goals and uses. Every view has its own goal and its own uses. Different views will support different goals and uses. That is the main use of choosing relevant views. Okay, na? This is fundamentally why we do not advocate a particular view or a collection of views. So according to this reason, fundamentally why we not advocate a particular view or a collection of views. Enduku manu oka view meede depend avvamu, enduku manu oka collection of views meede manam advocate avvamu ante it will be depends upon the particular use, particular situation. Okay na? It will be depends. The view you should document depend on the uses you expect to make of the documentation. మనం యూస్ని సెలెక్ట్ చేసుకునేటప్పుడు ఈ వ్యూ షుడ్ డాక్యుమెంట్ దేని మీద డిపెండ్ అవుతుంది? డిపెండ్స్ అపాన్ ద యూజెస్ మెయిన్లీ. యూ ఎక్స్పెక్ట్ వాట్ వీ ఎక్స్పెక్ట్ టు మేక్ ఆఫ్ ద డాక్యుమెంటేషన్. డిఫరెంట్ వ్యూస్ విల్ హైలైట్ డిఫరెంట్ సిస్టమ్ ఎలిమెంట్స్. సో బట్ ద డిఫరెంట్ వ్యూస్ వల్ల మనకు మెయిన్ ఫస్ట్ వ్యూస్ ఏం చెప్పుకున్నాము? ఈ డిఫరెంట్ వ్యూస్ హ్యావ్ సపోర్ట్ డిఫరెంట్ గోల్స్ అండ్ యూజెస్, and also these different views will highlight different system elements or relationships. These views will give the different system elements. Okay na? Okoka view lo okoka type of elements we are using, and also we can explain about the relationship among them, as I said in the previous slide. That is the main use of this views. Next, the views divided into three groups. In generally, the views divided into three groups. They are, first one, module view, second one, component and connectors view. In short, we can call it as a C and C. C and C means what? It abbreviates component and connectors. C means component, and symbol means and. Another C is connector view. Third one, allocation view. These are the three different views we can see here. So, first one, module view, second one, component and connectors view, third one, allocation view. Okay. In these three ways, categorization reflects the fact that architects need to think about their software in at least three ways at once. Okay, now that is the main use. Next, first one, what are the three ways at once means how it is structured as a set of implementation units. ఎందుకు మనం ఈ త్రీ వేస్ని మనం కేటగిరీ యూస్ చేస్తున్నామంటే ఇట్ విల్ బి మెయిన్లీ ఫోకసింగ్ ఆన్ దీస్ పాయింట్స్. హౌ ఇట్ ఈజ్ స్ట్రక్చర్డ్ యాజ్ ఎ సెట్ ఆఫ్ ఇంప్లిమెంటేషన్ యూనిట్స్ and how it is structured as a set of elements, set of implementation units. Here in the second point, set of elements that have runtime behavior and interactions. Runtime behavior and interactions. Third one, how it relates to non-software structures in its environment. For this, we are choosing these particular views. Okay. First one, how it is structured at the set of implementation units. Second one, how it is structured as a set of elements that have runtime behavior and interactions. Third one, how it relates to non-software structures in its environment. Next, in other views are also available. So, what are those other views? They also having set of system elements and their relationships among them. So, according to this, these elements and relationships you deem useful to a segment of the stakeholders community. Okay, now these other elements also useful. Why? Because they are also uses some elements and they also having some their relationships. They are useful for some segments, for some parts of the particular structure. These also constitute a valid views. Here a simple 3 steps procedure to choose the views for your project. First one, ఈ వ్యూస్ని మనం సెలెక్ట్ చేసుకోవడానికి సింపుల్ 3 steps procedure you need to follow. First one, produce a candidate view list. First we can produce a candidate view list. By building a stakeholder or view table for your project, first we can building a stakeholder or a view table for your project. First we can prepare it. Your stakeholder list is likely to be different from the one is the table, but be as comprehensive as you can. For the columns, enumerate the views that apply to your system. Some views apply to every system, while others only apply to systems designed that way. Means the layered views most component and connector views such as client server or shared data. For example, according to that usage we can make the tables. Once you have the rows and columns defined, according to requirement wise we make a table in the form of rows and columns. Fill in each cell to describe how much information the stakeholders requires from the view. So, according to that we can maintain the rows and columns. We can fill the cells. Cells means rows and columns means we need to fill the cells. Okay, na? The A tuple is nothing but a cell. It is the tuple is is a combination of row and column, that is called as a cell. In this cell we need to fill the information. It describes what which type of requirements the user having, the stakeholders requires. Okay, none other view only, moderate detail or high detail. వాళ్ళు ఏమి వాళ్ళకి అవసరం లేదు, ఏ ఇన్ఫర్మేషన్ లేదా ఈ స్టేక్ హోల్డర్కి, లేదా ఓవర్ వ్యూ ఓన్లీ సమ్ వ్యూస్ మీద వాళ్ళకి ఇన్ఫర్మేషన్ కావాలా, మోడరేట్ డీటెయిల్స్ కావాలా, హై డీటెయిల్స్ కావాలా, ఇలా అకార్డింగ్ టు దట్ రిక్వైర్మెంట్స్ ఆఫ్ ద స్టేక్ హోల్డర్స్ వీ నీడ్ టు మెయింటైన్ ద టేబుల్ according to views also. Next, combine views. Then we can combine views. So based on the stakeholders, which type of stakeholders requires which type of information, elaborate information, high detailed information, or absolute information, accuracy type of information. Based on that we need to combine the views. That is the meaning. The candidate will list the step 1 is likely to yield the impartially large number of views. To reduce the list of manageable size, first look for view in the table that requires only overview depth or the serve very few stakeholders. Next, see if the stakeholders could be equally well served by another views having a stronger consistency. Next, look for view that are good candidates be combined. For small and medium project, the implementation view is often easily overwhelmed with the module decomposition view. The module decomposition view also pairs well with users and layered views. Okay, now finally the documentation view usually combines with whatever component and connector views shows the components that are allocated to hardware elements. The process view is the example for it. So according to we need to combine them. Okay, na? We need to combine the views. First we can decomposition the module views, then we can combine them according to that particular modules. Next, prioritize. After step 2 you should have an appropriate set of views to serve your stakeholders community. Then we can prioritize. First we can choose this, then we can combine them, then we can prioritize them, appropriate set of views to serve our stakeholders community. At this point you need to decide what to do first, and how you decide depends on the details specific to your project. But remember that you didn't have to complete one view before starting another. So ఏది తీసుకున్నా కానీ ప్రయారిటైజేషన్ చేసేటప్పుడు which one is first, which one is next, ఒకటి కంప్లీట్ కాకుండా ఇంకొక దాన్ని మనం చేయలేము. దట్ ఈస్ ద మీనింగ్. బట్ రిమెంబర్ దట్ యూ డిడెంట్ హ్యావ్ టు కంప్లీట్ వన్ వ్యూ బిఫోర్ స్టార్టింగ్ అనదర్. Okay, that is the thing. Next, people can make progress with overview level information. So the breadth first approach is often be best. Also some stakeholders interest superset others. A project manager or the management of a company with which you is partnering demands attention and information early and often. According to that managers, according to the management of a company with which yours is partnering demands, వాళ్ళకు partners ఉంటారు, according to that partners demanding attention and information early and often according to them. Next, second one, documenting a view. First one, choosing the views, then documenting a view. Choose చేసినటువంటి views ని మనం ఏం చేయాలి? నెక్స్ట్ స్టెప్, నెక్స్ట్ టైప్ ఆఫ్ వ్యూలో డాక్యుమెంటింగ్ ఏ వ్యూ. There is no industry standard template for documenting a view. ఇక్కడ ఏ ఇండస్ట్రీ స్టాండర్డ్ టెంప్లెట్ కానీ బ్లూ ప్రింట్స్ కానీ ఉండవు వ్యూస్ని డాక్యుమెంట్ చేయడానికి. బట్ ద 7-part స్టాండర్డ్ ఆర్గనైజేషన్ that we suggest in this section, but we can follow 7 steps standard organization. First of all, whether a section you choose to include, make sure you have standard organization. Allocating specific information to specific sections will help the documentation writer attack the task and recognize completion, and it will help the documentation reader quickly find information of interest at the moment and skip everything else. మనకి ఇప్పుడు టెక్స్ట్, సపోజ్ వీఆర్ టేకింగ్ ద టెక్స్ట్ బుక్, దట్ ఈజ్ ఆల్సో ఏ డాక్యుమెంటేషన్. డాక్యుమెంటేషన్ చేసేటప్పుడు ఏ డాక్యుమెంటేషన్ రైటర్ అటాక్ ద టాస్క్ అండ్ రికగ్నైజ్ ద కంప్లీషన్. ఎందుకు రికగ్నైజ్ చేయాలి అంటే దే కెన్ బి అండర్స్టూడ్ ద రీడర్స్ ఆల్సో. రీడర్స్ ఏం కోరుకుంటారు? ద రీడర్స్ వాంట్ టు ఫైండ్ క్విక్లీ వాట్ ఎవర్ ది ఇన్ఫర్మేషన్ దే వాంట్, అండ్ దే వాంట్ టు స్కిప్ సంథింగ్ ఫ్రమ్ వేర్ ఎల్స్. దట్స్ వై ఇప్పుడు మన టెక్స్ట్ బుక్ ఉంది, టెక్స్ట్ బుక్లో మనం 400 పేజీకి వెళ్ళాలంటే అకార్డింగ్ టు సమ్ కాన్సెప్ట్ మనం ఫస్ట్ వీ కెన్ చెక్ ఫర్ ఇండెక్స్. So that is very important. You will go through somewhere else in a particular in-depth concept of our textbook. Easily we will go through it. We can navigate it. That is the documentation important. Even the reader quickly find the information what he want, and also at that moment he want to skip everything else also. Akkada nunchi vellipovalante easy ga he want to move it. That is the importance of documentation. Then in here we can follow the steps. First one, primary presentation. This shows the elements and relationships among the populated the views. This primary presentation shows the elements and relationships among that. The primary presentation should also contain the information you wish to convey about the system. This primary presentation is also have the information to convey the system, means vocabulary. First, it should certainly include the primary elements and relationships of the view, but under some circumstances it might not include all of them. According to some restrictions, some circumstances, it does not include all of them. Okay na. And this primary presentation, for example, you can see you may wish to show the elements and relationships that come into play during normal operation, but relegates error handling or exceptional processing to the supporting documentation. The primary presentation is usually graphical. The primary presentation is usually graphical. In fact, most graphical notations make their own contribution in the form of the primary presentation and little else. They can give the make more presentation. If the primary presentation is graphical, it must be accompanied by a key that explains or that points to an explanation of the notation or symbology used. మనం ఈజీగా అర్థం చేసుకోవడానికి it will be in the graphical notation. It will be also follow some symbological notations also. Sometimes the primary presentation can be tabular. Tables are often be superb way to convey a large amount of information compactly. Large information ni manamu easy ga convey cheyadaniki we are also use the tabular format. That is also a primary presentation. Next, elements catalog details. So మనము ఒక హోటల్కి వెళ్ళినప్పుడు యూ వాంట్ టు ఆర్డర్ సంథింగ్, సో యూ ఫస్ట్ వీ నీడ్ టు సీ ద catalog book. In this the all things are there, for example veg, non-veg and snack items and all. So you need to pick someone among them. So while seeing that our interest will go through some others. Our mind is one but while seeing that catalog we will go for, but we want to know what are those in this particular hotel. Okay na, you have to see this particular catalog. That catalog gives the information what will be having according to the particular sections. That is the meaning of elements catalog details. Okay, at least those elements and relations depends on the primary presentation and perhaps others. Producing the primary presentation is often what architects concentrate on, but without backup information. That is the main thing. Next, context diagram. The context diagram, what is the use of context diagram? The context diagram gives the overview of the system. Block diagram is describe the entire parts of the system, but the context diagram gives the overview of the system. So that is also one way. So how to documenting view? Context diagram. It shows how the system depicted in the view relates to its environment in the vocabulary of the view. For example, in a component and connectors view, you show which component and connectors interact with the external components and connectors via which interacts and protocols. That is the main importance. Next, variability guide. We need, here we can follow the some guide also. It provides some guide also. What shows this variability guide? It shows how to exercise any variation points that are a part of the architecture shown in this particular views. In some architectures, decisions are left unbound until a large stage of the development process, and yet the architecture must still be documented. Next, architecture background. You can also see the architecture background. It explains why the design reflected in the view came to be. The goal of this section is to explain to someone why the design is as it is and to provide a convening arrangement to that particular ones. That is the main importance of this architectural background. This architectural background includes rational, analysis results, assumptions. That is the architectural background. This will be having, it will be including rational. It explaining why the decisions reflected in the view were made and why alternatives were rejected. So that is the rational. Analysis results. This analysis results justifies the design or explain what would have to change in the phase of a modification. మనం ఏం మోడిఫికేషన్ చేయాలి అనేది ఇది జస్టిఫై చేస్తుంది ఇన్ పర్టికులర్ డిజైన్. Assumptions reflected in the design. So according to that analysis we can think something, we can assuming something, it reflect the design. Next one, గ్లోసరీ ఆఫ్ ఐటమ్స్. గ్లోసరీ ఆఫ్ ఐటమ్ మీన్స్ ఒక షాప్కి మనం వెళ్ళినప్పుడు ఐటమ్స్ని మనం ఎలా పెడతాము, సపోజ్ ఫుడ్ ఐటమ్స్ అన్నీ ఒక ర్యాక్లో ఉంటాయి, లేకపోతే సోప్స్ ఇలాంటివన్నీ ఒక ర్యాక్లో అరేంజ్ చేస్తారు, చిల్డ్రన్స్ ఐటమ్స్ అన్నీ ఒక దగ్గర అరేంజ్ చేస్తారు, ఓకేనా, కిచెన్ ఐటమ్స్ అన్నీ ఒక దగ్గర అరేంజ్ చేస్తారు. అంటే గ్రాసరీ ఆఫ్ ఐటమ్స్ ఎలా అయితే అరేంజ్ చేస్తారో అలా దీస్ గ్రాసరీ ఆఫ్ టర్మ్స్ యూజ్డ్ ఇన్ ద వ్యూస్ విత్ ఏ బ్రీఫ్ డిస్క్రిప్షన్ ఆఫ్ ఈచ్. ఎందుకు ఇలా అరేంజ్ చేస్తారు ఈ టర్మ్స్ అంటే బ్రీఫ్ డిస్కషన్ ఆఫ్ ఈచ్. నెక్స్ట్ అదర్ ఇన్ఫర్మేషన్. దే మైట్ ఇంక్లూడ్ మేనేజ్మెంట్ ఇన్ఫర్మేషన్ సచ్ యాజ్ authorship, configuration control data and change histories. The architect might record references to specific sections to a requirement document to establish traceability. Strictly speaking, information such as this is not architectural. So these are the things, 7 ways we need to follow while documenting a view. First step, primary presentation. Second one, elements catalog details. Third one, context diagram. Fourth one, variability guide. Fifth one, architectural background, glossary of items. Sixth one, seventh one, other information. You have to follow these steps while documenting the view. Okay, I hope all you understood. This is a block diagram for 7 parts of the documenting a view. What we explained we will be briefly having in this session. So what is the first one? Primary presentation view. So, we have to check the particular presentation, according to we can act. Next, element catalog. In this what we can do, elements and other properties and relations and their properties, element interfaces, element behavior. So, then context diagram. This context diagram shows the overview of a particular system. Okay, now how it will be. Suppose we are taking the computer. What is the context diagram of a computer? The computer takes the information and process the information and produce the output. Input, computer, block diagram, computer and output. That is the context diagram of a computer. As well as this is a shows this is a system. It will having some components and also it will maintain some relationships among them. Okay, now that is the main thing of context diagram. It explains, it describes the overview of a system. Next, variability guide. Next, architecture background. It explain about design relational analysis results and assumptions. Next, glossary of terms and other information. This is the block diagram for documenting a view with the use of 7 steps. Then I hope all you understood how we documenting the views. Okay, now so we can discuss different concepts. In the next class we are going to discuss about documenting behavior and documenting interfaces and documentation across views. Okay, we are going to discuss in the next class. I hope all you understood regarding to views. Thank you one and all.